Welcome everyone to this episode of Green Talks. We are back to talk about research on sustainable and smart separation process engineering in the chemical industry. I'm Thomas Setche, your student host once again from Green Hub Twente. Today we can welcome Professor Dr. Engineer Boelo Schuur, who will talk about his specific research and much more related to SDGs. Mr. Boelo is a professor of separation technology in process and catalyst engineering, with key research in development and sustainability of separation process in chemical operations. Some applications may include biorefinery and circular economy as key topics. Thank you, Boelo, for accepting our invitation. Could you please tell us about your academic background, what a separation technologist is, and what is your research focusing on?
Yeah, thank you very much for the invitation to start with. As a separation technologist, I was trained as a chemical engineer in general, and I received my training in Groningen at the University of Groningen with a very broad basis, a lot related to chemistry. And I also say always I'm a chemical engineer with a capital C in comparison to other chemical engineers who are maybe more related to mechanical engineering. Mm-hmm. And so our field is a field with connections to biology, to chemistry, and to mechanical engineering. And in that field, I am more close to the chemistry than to the real, materials used for equipment building and those kind of things. So I look a lot into development of new molecules and how to separate certain molecules that are maybe typically not so easily separated. And so how to solve different separation challenges. Starting in Groningen, I moved to Eindhoven and spent a bit of time in the US, and then came back. And in 2011, I moved to Twente. And since 2011, I develop here projects and run projects on separation technology with a wide variety of applications. And I think that is the key. For me, there is not just one field of application, and I don't do in a very limited scope my work, but I try to apply the same separation principles for numerous fields, including textiles or bulk chemicals or fine chemicals or water treatment, and I think that by doing different subjects you can also learn and take something over the borders of a certain field and then bring new ideas into a field that is helping them to become more sustainable.
Yeah, we love to hear about perspectives and bringing ideas and innovation together. I do want to stress out that you were a visiting researcher at MIT in the US and in Lisbon. So, yeah, big congratulations to that. And you have been working at the UT since 2011. That's quite a long time.
Yeah, well, that is basically after walking around in different areas of the world. Yeah. Well, not so much, actually. I was in the US and in Lisbon for both of them for a relatively short period of time. I spent longer time in Eindhoven. But basically, if you found the position where you can grow, where you are in a good place, where the people take care of you, and where you are also able to care about people, and within a research group where you really can do what you think is making a difference, then there's no need to move.
Wow, making a difference. So inspirational. All right, so before we go a bit more deep into sustainability and what separation process is, I mean, you already kind of explained the importance and what you really do, but I want to ask you this very question. What is your most unsustainable guilty pleasure?
Well, I drive a 2-liter turbocharged engine in my car. I still don't have an electric car.
Not yet.
and when I'm driving it in Germany, I also like to speed, and it is emitting a lot of CO2.
Yeah. You like to separate yourself from the slow goers. Very nice. Okay, well, we're gonna hear why you chose sustainability as your interest, and what motivated you to explore the sustainable side of separation process engineering. So yeah, tell us about your motivation in bringing innovation into this crucially unsustainable industry.
Well, I think the most important step is that if you decide for a career in academia, then you decide for a career not maintaining what is there. Yeah? If you are a maintenance engineer in an oil company, you try to keep drilling oil as long as possible, right? If you choose your career in academia, usually the drive is to contribute to new technology development. And at the moment that I started my career, it was already making processes more energy efficient. But maybe in the very beginning, and that not necessarily was directly related to CO2 emissions, because that was way before the Paris Agreement, and the world was still thinking that the oil reserves were dwindling, but not necessarily considering that also the CO2 emission that is related to use of oil as a source for all our products is very important. At that time, the dwindling oil reserves that are actually not so much dwindling. There is enough oil to continue for many years. So that is not a problem at all. The real problem is that if we look at where are all our carbon atoms, then we are shifting more and more carbon atoms from deep under the soil into the atmosphere, or carbon in the form of CO2. It's probably also ending up in the sea at some point. There is an equilibrium between the sea and the atmosphere. And that is something that nowadays many people are very concerned about. That's shifted a bit. And so when I was younger, you could say that becoming more energy efficient is a way to be cheaper.
Yeah.
And when I was a student even, one of my professors told us as students, there is three things important in chemical engineering. And one is money, and the second is money, and the third is money.
Is also money.
Right? And so everything is expressed in at that time still guilders, but nowadays in euros. And still you could argue that for big companies, if you don't make a profit, also for small companies, if you're in industry and you don't make a profit, then it's very hard to sustain. Right? So that is one aspect that we should not forget. But at the same time, there's a shift in attention. And over the years, what you do is you just grow with the field. That's not necessarily following the field, but maybe the more you are into it and the more you feel what are the powers that are involved, you try to lead the field and lead the pack and guide industries and other universities, maybe university professors or younger researchers into the science that you think is helping to reduce CO2 emissions and helping to reduce emissions in general.
Yeah, so the impact, or let's say the importance of sustainable change is very important for you now compared to maybe your childhood. And you're trying also to drive the shift, and we're going to talk about that. How do you try to represent yourself to drive the shift to sustainability and circularity as well? Thank you for answering this question. To me, it's very clear where does sustainability come into your life. Now, I would like to go a bit more specific when it comes to sustainability and talk about the UN SDGs, the Sustainable Development Goals, and ask you which SDGs do you think are most closely linked to your work when it comes to sustainable separation engineering, and how do you see your research contributing to these goals?
Yeah, there is in total there are 17 sustainability goals. There is 5 of them I picked as the ones that are really relevant for me. Of course, all of them are relevant for us as human beings in our life, but things like poverty I cannot directly change with my separation research. So I focus on clean water, that is an important one, and affordable and clean energy. In industry, innovation and infrastructure, that is an important one, and then sustainable cities and communities. And the last one is responsible consumption and production. And I think number 6, the clean water, and number 12, the responsible production. Those are the ones that are by far most often addressed in the research that I conduct.
Thank you. Wonderful. And now it's time that we start talking about your research. So tell us about research in sustainable separation engineering and perhaps some innovative technologies that you are working on to make this separation process more sustainable. So where does sustainability come into the play?
Yeah. So I already mentioned by the pre-last question, when I was a PhD student, I was already working on biodiesel and on renewable energy. At that time, maybe a big driver was economy, was market value, and if you would be more sustainable, at that time we just saw it as using less energy and reducing the energy bill. And that is a key aspect. If we look at what is the impact for the environment, the total amount of energy that is used by separation processes around the world is 15%. So there is, if you account for all the distillation columns all over the world, this is a huge impact. And if we can reduce one major separation technology impact by, let's say, 5 or 10%, as a relatively moderate improvement, you can imagine that's already going to have a huge impact on the total. Now, towards 2050, we don't want 5 or 10% differences. So we want a huge improvement. So we need not only to have, let's say, incremental improvements, but we need to have a total change in the order of magnitude of things that we are doing. And that's going to be difficult. But there are key steps that I consider important. One of them is maybe you don't want to do all the separations that we do nowadays. You can replace them for newer technologies. And I mentioned distillations, those are the benchmark. And often what I try to do is replace a distillation for an affinity separation. And an affinity separation is a separation that I consider a separation where there is a solvent involved or a sorbent. That's a chemical that binds to the chemical that you want to separate out of a mixture. So if you have a mixture of multiple compounds, then one of the compounds is attracted more than the others. And by the use of such a solvent, you could initiate a separation. But typically, what is important is that if you use a solvent, you end up with your molecule that you wanted to have is present in a solvent. So the next step is that in order to get it out of the solvent, you need, usually in traditional industry, again do a distillation. And while we can replace the original distillation with a more efficient one, during the regeneration, we can make energy improvements. But what we are nowadays more and more looking into it is into smart separations where we use a solvent or a sorbent that can actually change the properties under influence of a stimulus. And by doing that, we generate a solvent that is maybe ideal for the regeneration. Because the whole point is that if I make a solvent that is ideal for my extraction, then it's typically not ideal for the regeneration. Because the better it extracts molecules and keeps them bound, the more energy it will cost to regenerate that solvent. So I have basically two driving forces. One is the driving force for my primary separation, and one is the regeneration of that agent. And if I don't use a smart separation, I cannot make them both optimal. And by using a smart separation, we hope that we can change the dependency on, let's say, burning gas as an energy source to do the regeneration. And maybe we can make a more green source of energy, for example, green electricity, as input for such a regeneration process. And that is driving the current research a lot.
Yeah, I can understand how this really could make a huge impact, like just making these small changes into the process itself. Yeah, I think it's very technical, obviously, very practical, but also you can see your impact right away, and it's probably also very complex. I can understand. So next off, I would like to
maybe one
Yes,
thing to
please.
add to that. Typically, if it's simple and if it's low hanging fruit, then companies will never come to the university. Right? We're not solving their
Very
easy
good point.
challenges.
Very good point. All right, so let's discuss how these innovations that you just told me about could contribute to achieving, let's say, SDG 12, and how could you measure, let's say, the impact of these. So the impact of, let's say, implementing green electricity in these processes, or innovations like the small separation, and what else, or what other specific steps do we need to take to improve sustainability in, let's say, in the chemical industry?
Yeah, I think one aspect that is overlooked a bit is how much industries often themselves are already doing. And the problem with developing chemical processes is that it takes typically around 20 years. When you come with a new idea, one example is a very nice one, is the use of ionic liquids. These are liquid salts. So basically they are a salt, but their structure is so complex, the molecules, or the ions I should say, they are so complex that it's not easy to crystallize. And so they still are liquid at room temperature. And in the early 2000s, they were really being hyped and a lot of science was done, but it took a long time before they found their way into industry. And now, 2 years ago, at the oil company Chevron, they implemented new ionic liquid technology to replace an HF-based plant. And HF, hydrofluoric acid, is one of the most dangerous acids there is. It's neurotoxic. And if you don't need it, you don't want it in your plant. And but for a long time, this was really the state of the art. And it took them basically 20 years to come from the idea to implementation on the full scale. And what we see, we talked earlier about 2011, me coming to Twente. What is the time frame? In the earliest days, any invention that I would have done at that time, when would you expect to see it on a full scale? It's probably not before 2025, right? And so it is very difficult to say to what extent is something already, let's say, on an industrial scale possible. That is one thing. And I think a key step here is that always, if we do an invention here, I usually work with companies. So we work in a public-private partnership where a company typically funds with cash, and the university funds with in-kind. So that means that I give my hours to the project, and the company gives cash, so then we can hire a PhD student to do the research. And we always organize these kind of projects in a way that it is fundamental science. I don't want to be a consultant of industry. Right, so it's very important that it is fundamental science that the society can benefit from, but that there is a direct link to applications in those industries. And so by organizing the research in such a way, it is possible to let new ideas and new concepts directly land at the parties that can also do something with it later on. Because what we don't want to do is invent something and then put it that it is left over somewhere in the shelf in our academic ivory tower. And it should really land in the industries. And by doing these PPP things, I think that helps.
Yeah, and even this takes a lot of time, I believe, even if you have like partners, right next door.
Yeah, the good thing is, and you know that your idea is landing in the right place, but then after it has landed, they need to take several steps. Because typically, if you have something that works on a laboratory scale, and you want to build a factory, what people do is they first make a pilot plant, and then maybe a demo plant, and then the full scale. And in every step, in industry, maybe they face problems on the demo scale that I could have never foreseen on the laboratory scale. And that's simply how life works. And That is also a little bit a hurdle, not a little bit, a big hurdle, if you consider the time scale that people want us to make changes. We cannot change and say, well, next year we're not going to use oil anymore. Right, and because what are we going to do then? We're not ready for the total change in such a short time.
Yeah, for the alternatives. Yeah, I understand. Yeah. Maybe then it's a fairly good question to ask. How do you think the concept of then sustainability and circular economy will become important in the chemical industry, let's say, in the coming years, and what's your role to play in this shift?
And there is an increasing awareness of the trouble that is ongoing. And in the Netherlands, you may be aware of the nitrogen problem, as we tend to call it. But this is just one aspect. And there is another problem that is arising in, for example, in the south, in the Westerschelde, they face quite dramatically high concentrations of PFAS. But it's actually not only there in this waterway that is directly related to a chemical industry that is located close to the waterway, but also in other places there are. And so we are in that case in seeing the chemicals that come from over the border from Belgium. But we see throughout our society that we end up with PFAS that's not being reduced, and it's a fairly sustainable chemical in that sense that it doesn't break down, and you don't want that. So what we need to do is find a solution for cleaning up this PFAS, and we have nitrogen, we have PFAS, we have other things as well, and we see now more and more. Actually, our technological development allows us to do much more accurate analysis. And so we are more and more aware of what is in our environment. And maybe things that are starting to get there in the 1950s, 1960s. At that time, nobody was aware of them because they could also not be measured. And we see a tremendous growth over the past 25 years in the accuracy of our analysis, and also in the awareness of the people that what is in maybe our surface waters and in our environment is not per se below health risking limits. And so we see that especially chemical industries, they know that if there is a PFAS problem around their corner, for example, if you are a company that uses surface water in order to cool your equipment, but at the time that you discharge this surface water again, and you have to show to the government what is in there, and there is PFAS in there, and then all of a sudden you are the owner of the problem, right? Whereas maybe you were not even the company that put this PFAS in there. So that is where we see now that chemical industries in the Netherlands are extremely worried about these kind of, let's say, limits to their permit to operate. And for that reason, they are very open to collaborate with us in developing separation technology that could, for example, get PFAS out of surface water.
Yeah, they feel it's their responsibility.
Yes, or to come up with alternative routes. And one important thing is we have a new project coming up that's just granted that's called Reblocks. And it is about renewable building blocks from complex waste, from complex and wet waste. And where we try to get, let's say, the outflow of industries or from wastewater installations, or from just like here around the corner, we have Twente, there is EEW in the north of the Netherlands. These are waste treatment installations. What comes out of their installation is not necessarily ready to be used as a feedstock in chemical industries. So we are developing processes that can transform waste into new building blocks. And what you see is that there typically what is important is you have a conversion step, like we talk about what is separation. And well, you have conversion, you have chemical reactions. And after the chemical reactions, you need to see what is in my mixture that comes out of the plant. And to send it to a next plant as feedstock, the feedstock need to have a certain composition. There may not be impurities that are limiting operability, or even legal limitations, like there is maybe too much chlorine in there. And how does chlorine ends up in there? Well, maybe if you have waste treatment and there is some PVC that contains chlorine, that means that the outflow of your factory should somehow have reduced the chlorine concentration. So you need to get it out. Well, these are challenges where we are currently facing. And we do the research together with several smaller companies that have technology developed, so they can operate on the relatively small pilot scale. And we, as a research institute at the University of Twente, we analyze what is in the outflow of the technology, and we come up with technical solutions in terms of separation technology, how to get these molecules out.
Yeah, to be honest, I really like this application of, or this perspective of circular economy, of looking at the byproducts, but it's not obvious how those byproducts can be applied, and if those byproducts are even ready to be applied, and then maybe you need the separation process to be able to create a circular economy. So to me, it's really clear the essence, or maybe the relevance of separation engineering for circular economy. One doesn't go without the other, especially when it comes to chemical industry, because we talk a lot about supply chains, like in our previous podcast as well. We talk about the food industry, because there it's maybe somewhat easier to make circular economy, but when it comes to chemical industry, where you have a lot of solvents, as you say, and a lot of unsustainable materials, how do you manage to get circular economy? And I think you gave us a very insightful and interesting answer. So we talked a lot about applications. So you already answered quite a few of my questions as well. I would like to maybe turn a bit back now to academia and education, and let's talk about our university. So in your experience, how do you think universities could best support these efforts to achieve SDGs, and what role does your teaching play in this regard?
Yeah, well, I said one of the first answers included the statement about money, money, and money. And in my opinion, it's very important that what I teach in the master course on separations is that the most important focus should be on the amount of energy that you use in the first place. And then, because that is also a measure of the CO2 emission. So instead of putting the full focus on your total annual income, put a focus on how sustainable can your process be. And that is, I think, a different perspective. And coming back to the previous answer, where I answered on, let's say, the license to operate, I think in the future, more and more for companies, a limiting license to operate is a serious threat. And that means that also for them, CO2 emissions and other emissions, nitrogen emissions and maybe heavy metals, is going to be very important. And that means that the tools that our engineers that graduate here have are really important for working in these companies. So that is the reason why I put so much emphasis on emissions and how to reduce that, and how to, let's say, operate at the least energy required.
Okay, I see how you try to integrate emissions, maybe SDGs and sustainability in teaching, but how do you make sure that these SDGs are also reflected, integrated, and respected by the partners or companies that you're working with? I mean, I understand their motivation also to work on such projects with you, but how do you make sure that they actually satisfy or look up to those SDGs on which you're also trying to work on?
Yeah, it's very difficult, and I'm not sure if I can. At some point, if it's out of control, it's not anymore part of a research project. Then I'm not a regulator in that sense. I'm not a lawmaker. I can say, well, you have to do this, and otherwise, there's just one small aspect maybe which could have a big impact. That is the contracts that we have as a university with companies. there is explicitly, and if we file a patent, the companies have the right to take that patent, but there is an anti-shelving rule in there. So this means that if a company is taking over a patent from the university, then they are not allowed to put it on the shelf with the simple goal of preventing others to use that technology. Yeah, because that's something what you could do, of course. And I think that is one rule that we have. And I have had already a few patents that have been filed, and where we should look basically what is going to happen with the patent. Is the company active? But it's not so easy actually to maintain the contact and to stay really focused on what are you doing with such a patent. It's also not my role, right? Yeah. So I think there we should not let's say aim to overreach.
Interesting. Yeah, I think this kind of summarizes, let's say, the top practical steps that you could take also to improve the industry sustainability practices as academia as well. Now, there is a question that I also believe you are so eager to answer, and that's about what are some of the misconceptions that people have when it comes to your field that you're conducting research in, so the sustainable separation process engineering.
Yeah, I mentioned the circular economy already, and one very important aspect in that sense is biorefinery. I want to use plants as a source to make products, because I believe if you use a plant as a source, then it has already taken up the CO2 from the atmosphere, and in contrary to drilling oil and at the end of the life of a product, just burn the product in a waste incinerator, you are transforming carbon from deep under the soil into CO2 in the atmosphere. By doing it with plants, you have a circular system, you have a circular economy in that sense. But I see in the last few years a lot of resistance against biomass. And sometimes I get the feeling that for many people in the Netherlands, they believe that biomass is a bad thing. And I think it's not. I do agree that it's not good to basically cut whole forests in Northern America and maybe in Scandinavia, ship those forests to the Netherlands to burn them in a power plant. And so that is not a good application of biomass. But if we consider that only 10% of all the oil that we currently use is used to make chemicals, that would mean that if you transform your market for materials based on biomass, and you accept that for energy applications you would have to use other things like wind energy, solar energy, then the burden that you put on the climate, let's say on biodiversity related aspects, is way smaller. So you are allowed, if you limit application of biomass in that sense, you are allowed, or you are able to make a bio-based economy without harming the environment. Right? In the second thing that is even more recent, I see there is a lot of opposition against fossil industries. And I do agree that they have not acted properly over the past 30 years or 50 years even, knowing already many decades ago that CO2 emissions are of importance for climate change. But putting them aside, cancelling them and not allowing them to participate in the challenge ahead of us, that would be a bad thing. Because these big companies, they have so much knowledge and they also have so much cash that if we exclude them from the game now onwards, we would lose maybe decades of time. And we don't have these decades of time. We want to change the world now. So I think my call is to not exclude the big oil companies, but to look how can we help them and together with them change our economy into a more sustainable one.
Okay, yeah, thank you for answering these misconceptions. I think it's very important that we tackled these in this episode. Perhaps a little follow-up question, which is, again, difficult to answer, is a follow-up to this. So how could you make sure that greenwashing is not happening when it comes to the big oil companies? As you mentioned, in the last 50 years, they may have, and they haven't done enough to let's say satisfy and make sure that we drive the shift to sustainable change. How could you make sure that all the products? I mean, you mentioned the contract as well. Maybe you can help me summarize how we can tackle this challenge, this part of the challenge of, let's say, greenwashing.
Yeah. Well, one of the things that you have to consider when you are doing a research is how does that impact? Yeah, I've had companies willing to do a project with me for a relatively small amount of money, and they wanted to show what is, let's say, an LCA of a certain plastic kind of product. And at some point, I realized they were not really interested at all in circular plastic, but they wanted to use the LCA to show that their plastic product was maybe more or less unsustainable than another product. And at that point, I realized, no, this is not where I want to spend my time on. Right? But if you work on something where you believe in a biorefinery approach, where you typically work with a company that is really driving forward, then you also see that the people that are in that company are really willing to make the change. They are not willing to make a greenwashing step, but they really want to develop new technology. And also within the big companies that we are talking about, I see that there is maybe some managers, they are not interested in anything but just money. Yeah, but the scientists that we collaborate with, they are often very keen on developing new green processes, and they want to change the world also. So I think that is a key step. And then eventually, if it goes in the level where the company needs to make big decisions on, let's say, hundreds of millions of euros, yeah, there is nothing anymore what I as a scientist can do in the field of greenwashing or company decisions. That's up to them at that moment. But hopefully we plant the seed with very cool new technology that can save energy, that can enable a biorefinery or a circular process. And then once it's up to the investment decision, then hopefully the prospectus is good enough that they make that step.
Thank you very much. Very nice insights. There is one last topic that I would like to talk with you about, and that's you being a representative, and I want to underline a national representative of the chemical industries, sustainability, SDGs as well, and separation engineering. So could you tell us about your collaborations, your, let's say, chairmanship within organizations that are relevant to your field, relevant to driving the change as well?
Yeah. One of them is the European Federation of Chemical Engineering. I'm the secretary of the Working Party on Fluid Separations. So this is an organization where there are several working parties where specialists in that area they are working together. So in fluid separations, we have separation specialists from all over Europe, and it's a European federation, so it's mostly Europeans, but we also have guest specialists from China and from the US. But for all our member associations, we have people, and together we talk about what are the chief developments in terms of sustainability. Can we organize ourselves in such a way that we can drive the sustainability agenda forward? And in that sense, being part of that community where only a few people per nation are representing, yeah, that is really, I feel privileged to be part of that community, and also to be able to bring in my ideas about sustainable separations there, and together with my colleagues from all over Europe, to put that on the agenda.
Yeah, I'm very happy to mention this and also honor your participation as a representative of our university, and furthermore, I would like to mention that you were also a guest editor for a sustainability, so Green and Sustainable Chemistry journal. You have organized multiple events such as the NPS in 2014. You participated in ISEC. Could you tell us what that really means?
Yeah, so ISAC is the International Solvent Extraction Conference, and this conference is held every 3 years. Recently, it was a bit longer interval for the obvious reason, but last year we had again an ISAC, and there you see that the solvent extraction community gathers together, and then you have all the solvent specialists from all over the world being together in such a conference. And these are events, and I think they are very key for development, because what I see is something totally new I didn't think of in maybe one of the presentations, and then you are allowed to think a bit about it. When you are traveling back home, you can work out some ideas that you gathered in such an event. At the same time, having a plenary talk at such an event, you can also tell the world about what we do in Twente. And that is really cool. So it's really an honor. In the past few years, unfortunately, we had many conferences online, not being able to see each other. And for some time, we thought it could also be a sustainable solution, and to travel less and to just have online meetings. But I see it's really difficult, because the interactions that you have with other people, the great ideas you don't get at your computer at home, the great ideas you get if you talk more with people, and that is not possible in an online conference. So that is a little bit let's say a difficulty. And where you would have to think, okay, how often do I go to an international conference? How many miles do I travel? And what is the benefit? And but on average, I think that going to such a conference brings more for the world than that you spend on kilos of CO2 emitted.
Yeah, it's another unsustainable guilty pleasure, we can say.
Yeah, well, it's not only pleasure. I would say I like going to conferences, and I love the interaction and to create new ideas. But it's, in essence, it's also a critical part of my job, and I think that this is maybe one of the parts where I'm good at, is to come up with new innovative ideas that are out of the box, but they are sometimes based on a presentation that I see. I sometimes go to a conference that is a little bit outside my core area. And I do that on purpose, because then I can have maybe a technology transfer from that area into my field. And by that make a difference for the next decade of research in my group on what is going to be the subject. So I think that is an important one. It's not just a guilty pleasure, but it's a very important aspect of my work.
Yeah, especially when you don't just put it on the shelf, but you bring the insight to students. And I think from what I heard, that's what you do. So unfortunately, that was it for this time. I would like to ask you to give us a takeaway message after so much information and so many interesting topics. Might be difficult, but perhaps we can put it in such a way that as students, researchers, what should they take away from our little talk here when it comes to circular economy, when it comes to separation engineering, when it comes to the chemical industry, perhaps the big oil companies, and sustainability in general?
Yes, so I think that what is key here is that in our drive to make the world more sustainable and to come up with new innovative separation technology, at the same time that we are developing this technology, we are also developing the chemical engineers. And so our students are maybe the most important products that we have, because eventually they will come and work in companies, and they can make the difference inside the company. And I think the combination of educating new engineers with making really innovative new separation technology will help us in the next decades to transform our economy.
Wonderful. Thank you very much for being here. Thank you for all the insights and information that we could get out of this podcast episode. If people are interested, we have podcast episodes on circular economy with Devrim Yazan. We have talked with Pilar Ruiz about biorefineries as well, and bioliquids. So please, just look through our episodes, and we'll stay in touch. Thank you very much, Boelo, for being here with us.
Thank you very much
see
for
you
the
next
invitation.
time.